レガシーモダナイゼーション AI でコードに永遠の若さをもたらすと題しまして、GeneXus S.A、GeneXus テクニカルサポートマネージャー、ルイス・ムリーリョより講演いたします。この動画では、これまでご紹介した GeneXus Next とグローバントエンタープライズ AI を組み合わせたレガシーシステム再構築の新たなアプローチをご紹介します。COBOLのローン計算プログラムを実際に GeneXus へ移行するプロセスを実演します。それではご覧ください。
Hi, how are you? My name's Luis Murillo. I'm a tech manager at Globant, and we're going to be talking about legacy modernization. We'll be talking about the modernization of legacy systems. And by legacy systems, we mean all those that we're using in our organizations today. They perform their function very well, but they're written in obsolete technology. In old technology, old programming languages, that don't allow us to have the dynamism to maintain them with the level of updates that the current state of the art imposes. And why does this situation exist? Why are we talking about this? You know that 70% of banking systems today are legacy systems. And of those, 43% of the systems of the core banking systems are written in COBOL, an obsolete programming language that isn't taught in any universities today. So for this reason, since this pain point, this problem exists, we're bringing a solution. One possible solution, or why don't we just say, okay, let's throw all these systems out and rewrite them from scratch. Let's start from scratch with new solutions that serve our business. Well, because these systems store historical knowledge, an accumulation of knowledge about our business, and for that reason, they're known as digital assets within our company. What we want to do is not waste all this accumulated knowledge that exists within these systems to learn from them, and yes, update them and bring them to new technologies, new programming languages that allow us to quickly incorporate new practices and new functionalities. So for this talk, I have some bad news and some good news for you. The bad news is that even if we opt for that strategy of let's throw everything out and rewrite the whole system from scratch, the systems that we're writing today will be the legacy systems of tomorrow. So we have to have an alternative solution for this. And that is the good news. Unless this won't happen, unless we use a different approach to write our systems. And this is the solution that we, with the tools we have within Globant, are here to offer you. As Gilbert said, how to give your code eternal use. Or as we say on the GeneXus team, how to capture all the knowledge of your business in a knowledge base and have the code that's generated be a consequence of this formalized business knowledge base and have the code be written automatically. The solution we found for this problem, if we research the topic a bit, is that with the advent of generative artificial intelligence and large language models, we could eventually develop assistants that read the programs in the legacy language and transform them into the current language, or the one we want to convert to. While this is an acceptable approach to solving the problem, and we do use it to some extent, presented on its own, it has some flaws, which is what we'll be discussing next. Generative artificial intelligence? It's fine. It can understand the program written in a legacy programming language, but when it comes to converting it, it can have some kind of hallucinations. So the developer who is studying, controlling, and analyzing these assistants will have to study if the generated program matches the source program. And they'll have to do this by checking low-level abstraction languages, like the programming languages themselves. Additionally, every time this conversion process from one language to another occurs, as I mentioned earlier, these assistants can hallucinate. For the same input, you won't always get the same output. That is, two runs of the same assistant on the same source programming language can generate different programs in the destination language. So every time this process is performed, the developer in charge of this task will have to deal with low-level abstraction programming languages. Additionally, these converters don't have a holistic or general knowledge of the entire system they're converting. Well, that could be achieved, and we already have experience doing that, which we'll see later. Basically, what these assistants do is take one program and convert it to another program. And finally, this story, as I was saying, is going to repeat itself. When the language we're converting to today becomes a legacy language, this process of dealing with studying low-level languages, what the assistants are generating, will repeat every time our system becomes legacy. So what is the value proposition that we at Globant, with our tools, bring to add to this solution approach? What we're going to do is a mix of generative artificial intelligence, which in our case is called Globant Enterprise AI, with symbolic artificial intelligence, which in our tools is called GeneXus Next. Therefore, what our solution does is, we have a set of agents that read the programs or systems we want to convert from the legacy programming language, and what they generate are not programs in a new language, but rather they generate specifications about what these systems do. We feed those specifications into our architect within GeneXus Next, which is called Nexa. And what this architect does, which is also a solution developed on Globant Enterprise AI using generative artificial intelligence, is take these specifications from the system we're converting and generate GeneXus objects. GeneXus objects that have a much, much higher level of abstraction. Then, what we manage to do is, by having that knowledge encapsulated in our knowledge base through Nexa, that's where our symbolic artificial intelligence starts to work. Based on that knowledge base, it automatically generates the code and programs in a low-level language. What are the advantages of this solution? Well, the first is that this conversion process from a legacy system to a knowledge base is done at a much higher level of abstraction. The developer who has to control that process and the agents using generative AI, which, as we mentioned, we know can hallucinate, what they have to control are objects at a much higher level of abstraction. These are GeneXus objects that are inside our knowledge base. Then, the generation of the programs is a process that uses symbolic artificial intelligence, which doesn't have this problem of hallucinating. For the same input, we'll always get the same output. Therefore, the developer doesn't have to control the generation of programs in a low-level language. Okay, and when this process is repeated and we want to change the language we're generating in, we'll be working within the knowledge base. We'll be working at a much higher level of abstraction. And for the code generation, we'll be able to change the target language without having to control what's generated. Because for that code generation using symbolic artificial intelligence, we have 35 years of experience with our code generators within GeneXus Next. The solution then is based on our pillar tool that uses generative artificial intelligence with any of the large language models that exist today. As is our philosophy, whenever we develop a product, Globant Enterprise AI is a tool that is agnostic to the large language model it's using. Therefore, I define the assistance and abstract away from which large language model I'm going to use, and that is the pillar of our entire solution. Then, with Coda, to solve this particular problem, the tool we're using is GeneXus Next, which again, GeneXus Next, true to our philosophy, is agnostic to the programming language it generates and to the data and to the database it's going to use. Therefore, we also abstract away from that problem, and it's the combination of these two solutions, Globant Enterprise AI for generative AI and GeneXus Next for symbolic AI, that we use to solve these problems. So what we're going to do next is see a small proof of concept, putting all of this into action for a system written in COBOL that allows for loan requests and calculates the installments and interest. We take it, it's a system written in COBOL, we take it and convert it through this whole methodology into a system written, in particular, in .NET. Okay, here we see an application where we store the systems we're going to convert. Specifically, here we have the one I mentioned, where we're going to convert these COBOL programs for loan calculation. This is one of the programs on which we run one of our Globant Enterprise AI agents. What it does is, it captures its functionality from the code, tells us if it has a screen or not, if it uses a table, and writes pseudocode for the logic of what it does. This output from our Globant Enterprise AI agent, we feed it. Here we're seeing the GeneXus Next IDE, and we use the Nexa agent into which we feed this result from our agent. What Nexa does is capture that knowledge and it tells us, okay, with this knowledge, to make GeneXus objects, what we'd have to do is create some structured data types, some GeneXus procedures, and when we give it the okay, it generates them. As we can see, so far, it's not writing programs in any programming language. Instead, it's writing GeneX objects that the developer can study, analyze, and modify, and then they can be generated in any programming language. In this particular case, we're going to set it to generate .NET programs. Yes. And every time we want to generate them in any of the programming languages that GeneXus generates, what comes into play is the symbolic artificial intelligence that GeneXus uses. This is the one I mentioned, where for the same input, the output or the program we get is always the same. So here we see the system converted and generated in .NET with the same loan calculation functionality. Here we run it and enter a value. We want to know what the installment and interest would be for a $10,000 loan at 4% interest over 48 installments, and it gives us the result. Okay, so in this next video, what we're going to be looking at is something a bit more related to the data model, because obviously all of the applications we're going to convert will have a data model, or a database that they interact with. So we're going to show how our solution works for converting the tables and the database that the system uses. This second demo refers to a payroll system, and we're going to study two specific routines. One that gets an employee salary. It reads the employee table, and based on the employee's ID, which this routine receives as a parameter, it gets the salary. It also receives discounts as a parameter, so it calculates the final pay. We apply our Globant Enterprise AI agents to this routine, and it returns a full specification of what the routine does. For this particular case study, we're interested in seeing that it detects that it uses a table with an employee ID key, and it uses the salary field. What we do is we take the specification that our agent returns, and we feed it to Nexa, our architect within GeneXus Next, so that Nexa, based on this specification, can tell us which GeneX objects it should generate. Nexa, upon receiving this specification, says, okay, look, for what you've given me, what I should do is create a transaction object. In GeneXus, the transaction object not only automatically creates the table in the database we specify, but it also generates the programs to perform the CRUD operations, the updates for this table. So we tell it, okay, proceed, create this transaction with the name employees, and what GeneXus does is it creates a transaction type object for us with the two fields that this routine used. That is the employee ID and the salary. And here we see the transaction object created with these two fields. Next, what we're going to do is go back to our Globant Enterprise AI agents and analyze another routine. This other routine receives an employee ID, and by reading the corresponding table, it returns the employee's name. Right? This routine, although it uses the same table, from the perspective of the COBOL program we're analyzing, what our agent detects is that it uses a table that has an employee ID and an employee name. That's the table that the agent, within the entire analysis it did of this program, detects is being used in this program. We, once again, get this definition that our agent returned, and we feed it to Nexa inside the GeneXus Next IDE. When we feed this definition into GeneXus, to GeneXus Next? What Nexus says is, well, based on this, I should create an employee's transaction that has an employee ID and a name, but that's what I was saying about the holistic knowledge of the entire system that GeneXus has, and one of the advantages. GeneXus realizes that a table already exists with an employee ID and salary. So what it proposes, it tells us, you're the developer, you decide what to do, but one of the options I'm giving you is that instead of creating another transaction and another table, you add this field to the employee table we already have in the system. So when I give it the okay and say, perfect, do that, instead of creating another table or another transaction, it adds this name field to the employee table to the employee's transaction we already had in the system. This way, our table now has 3 fields. One more comment about the data model that we're going to convert in our system. We have 2 options. One is what we've been seeing, obtaining the tables used in the system. And with these tables, GeneXus will define a database normalized to the 3rd normal form. And that's one approach, one possible solution. But there are also cases where the client tells us, perfect, I want to convert the system, but for whatever reason, I want to keep using the same database. I don't want you to convert it. So this is another advantage we have in GeneXus Next. In GeneXus Next, we have a feature called the Database Reverse Engineering Tool, or DBRET for short. And this DBRET tool allows us to capture existing database structures and use them as if they were tables created within the knowledge base. Therefore, we could also, without needing to reconvert the database, use tables from the legacy system with the data that's already loaded. So to finish, I'll tell you what's next for us. We are working to make this whole process much smoother, much more integrated for all our tools. We're working to improve these generative artificial intelligence agents day by day so that the results obtained are increasingly accurate. What I'd like to offer is, if you have this problem, to reach out to us, reach out to Globant, where we can help you convert these legacy systems. We have our AI pods, yes, particularly Fast Code Studio, which is using these tools the most and from which we're getting the most feedback to improve them day by day. So reach out to us to achieve success stories with this problem. Well, that's all I had to share with you. So thank you very much for your time, and I hope to see you at Globant so we can achieve success stories together.
ありがとうございました。